Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is a continuation of hyperbolic functions for a differential calculus course. And we have just gone through a whole laundry list of videos, 3 different videos on an introduction to hyperbolic functions. Now we're into the calculus, which is the derivatives of hyperbolic functions. Now, I do want to mention up to this moment, because this is what most people are going to skip to if they can. I want to mention that the derivatives of the basic hyperbolic functions, these guys right here, those are generally memorizable. The hyperbolic identities, not all of them are memorizable. You should remember the basic identities, which are that sinh is odd and cosh is even, and this third one right here, which is the really kind of the birthplace of the hyperbolic trigonometric functions or hyperbolic functions, which are the cosh squared minus sinh squared is equal to 1. So those 3 are very important. The rest can be derived somewhat quickly if you needed them, but generally you won't need them. But again, derivatives, yeah, you're going to need these. So what's nice about the derivatives of the hyperbolic functions, they're almost the same as the derivatives of the trig functions. The way that I teach derivatives of trigonometric functions and their SIGN plus or minus signs is that if you have a trig function, whenever you take the derivative of a cofunction, like a cosine or a cosecant or a cotangent, its derivative will be negative. But that's not the case with the hyperbolic functions. The hyperbolic functions, the base 3, the big 3, sinh, cosh, and tanh, their derivatives are positive. Otherwise, they're pretty much like the trig functions, right? Derivative of the sinh is the cosh, derivative of the cosh is the positive sinh, derivative of the tanh is the sech squared. But when you go to the reciprocal functions, their derivatives, at least for the hyperbolics, are negative. Derivative of cosech is a negative cosech coth. Derivative of the sech is a negative sech tanh. And finally, derivative of the coth is a negative cosech squared. To prove any of these, all proofs with hyperbolic functions kind of revolve around the same idea. So we'll just prove maybe the derivative of the cosh just to showcase how this works. But they all kind of are done the same way. The derivative with respect to t, well, that I should say they are not all done the same way. Once you have the derivative of the cosh and the sinh, you can then use product or quotient rules, technically quotient rules, to prove the rest. But at least for the cosh and the derivative of the sinh, here's how you would do them. Derivative of the cosh is a derivative with respect to t of the exponential form of the cosh, e to the t plus e to the negative t over 2. And of course, that is, I'll factor out the half, the derivative with respect to t of e to the t plus e to the negative t. That was supposed to be a negative t, but obviously that did not work for me. And then the derivative of e to the t is e to the t. And derivative of e to the negative t is e to the negative t, but times the derivative of negative t, which is a negative 1. And as you can tell, that's e to the t minus e to the negative t all over 2, which is the sinh. Very fast, nice, clean proof. A single line, all it took for me. Again, if you want to prove the derivatives of the sech, I would not use that method. I would use the quotient rule. So if somebody said, what's the derivative? I want you to prove that the derivative of the sech is negative sech tanh. I would say, okay, great. Well, the sech is 1 over the cosh. And then I would use the quotient rule here. So the quotient rule says derivative of the top times the bottom minus the top times the derivative of the denominator all over that denominator squared. And that's negative sinh over cosh times 1 over cosh, or in other words, negative sech tanh. So that does work out. But that's how I would do those. Otherwise, the derivatives and stuff like that, like differentiate this, it's going to work very similar to all the other derivatives you've done. You just now know 6 more functions you can take derivatives of, but there's no new techniques. So for example, y prime here, this is a product rule. You have the product of a first function and a second function. So let's go ahead and take the derivative of that first function. Derivative of sech is a negative sech of t tanh of t times the second function, just writing that in, and then plus the first function, sech t, times the derivative of the second function. Well, this second function, the derivative of 1 is obviously still 0. The derivative of a natural log is 1 over its argument. So 1 over sech times, and then the derivative of its argument, which would be a negative sech of t tanh of t. Now this can be cleaned up a little bit, obviously, because you could see sech over sech there. Also, you could see that both terms in this derivative, both of them have a negative sech tanh. So I'm going to factor that negative sech tanh out. Negative sech of t tanh of t. And we'll be left with, on this first term right here, we'll be left with 1 plus the natural log of sech of t. In the second term, the sech's cancel beautifully. You'll be left with just a 1. Remember, we factor off a negative sech tanh. So in the end, this cleans up beautifully to just be a negative sech of t tanh of t times 2 plus natural log of sech of t. How many parentheses do I need there? 1 more. I'll actually block this in. There we go. All right. So that's the derivative of that. So it really is nothing super new. Just have to remember the derivative of the reciprocal functions are going to be negative.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.